Hello guys, welcome on Tesla Eduventures. In this video today we are going to discuss the quasi-static process. So you can see that there is a gas which is trapped in between a cylinder and a piston which is movable, and this piston is in equilibrium. Okay, which means the net force acting on this piston is zero. Outside the cylinder there is atmosphere, and in the other system there is vacuum on the other side of the piston, and same gas situated on the other side of the piston, and there is a pin which is used to hold the piston to its position. Now you can see that there is no pin in this case and piston is in equilibrium, which means that the atmospheric pressure and the pressure of the gas are same, and we can say that if we give a small velocity to this piston in this direction, a slight velocity, then this piston will start to move with that slight velocity in this direction, and it will continue to move in this direction. So this gas is expanding, but it is expanding very slowly, and this is called as the quasi-static process. But if we remove this pin suddenly, then the gas will expand against vacuum and this piston will accelerate towards the vacuum. So this process is not a quasi-static process. So we can say that free expansion is not a quasi-static process, and free expansion or this process is also irreversible process. We cannot reverse this process by the same path. I would be making a separate video on the reversible processes in the later on part, and in this case you can see that this piston is moving infinitely slow towards this side, and hence this is a reversible quasi-static process. Now whenever some heat is exchanged with the system, gaseous system, or some work is being done on that system, then that gas transits from one equilibrium state to another equilibrium state. But the path through which that gas transits from one equilibrium state to another equilibrium state does not essentially have constant state variables, which means that obviously when a gas transits from one state to another state, its state variables changes, like pressure, temperature, volume changes obviously, and they are not constant also at any instant of time. But we know that thermodynamics and laws of thermodynamics are only applicable when the gas is in thermal equilibrium state, which means that at all point of time the state variables of the gas should remain constant with time, instantaneously constant. So in any thermodynamical problem, we assume always that the system is in quasi-static equilibrium, which means that whether this system is transiting from one state to another state, it is transiting so slowly, so that it is having constant parameters or constant state variables like temperature, pressure and volume at each instant of time, and they are just changing in a wider span of time. The best example of this this fact is the growth of a child. If you observe the growth of a child instantaneously at any moment of time, then child will not seems to be growing. Its growth would be static at that moment of time. But eventually the child grows up, and you would notice the growth of the child eventually after long duration of time. In the same way, you can say that when the gas transits from one state to another state, you could not notice the state variables changing at any instant of time, but eventually after a long period of time those state variables would be changing, and hence this is a quasi-static process. So we can say that any process which we would study later on, isochoric, isobaric, isothermal and adiabatic, these are quasi-static processes because we have to assume them as quasi-static, because if we will not assume them quasi-static, then their state variables would not be constant at any instant of time, and therefore we could not apply the laws of thermodynamics on that system at any instant of time. So these problems and the solutions would not be valid. So there is an important thing also, that quasi-static process is reversible process, which means that we can just reverse that process in the reverse direction by the same path. And as I told that I would be making a separate video on the reversible processes in the later on part. Now the processes which are not quasi-static are irreversible also, because they could not be reversed by the same path, and we'll be discussing that thing in detail in the other video. So this is the quasi-static process, and in the next video I'll be coming with some more concepts about thermodynamics. Thank you.